Hi everyone, Miss Barker here again. We're going to keep working on calculating the volume and surface area of rectangular prisms and cubes, and today specifically we're going to be working on two volume real world problems. And then in your independent practice, you will also work on two volume problems that have a real world application. Okay, let's get started here. I'm going to start by reading this problem. Tasha's mom says she will buy Tasha enough candy. Oh, and I see a typo right there. I'm just going to fix it with my marker. Enough, don't need that T there, candy to fill a box for her birthday. If Tasha wants to get as much candy as possible, which of the two boxes should she pick? So really what we're going to try and do is figure out the volume of both of these rectangular prisms, and then Tasha wants as much candy as she can possibly get. So she's going to ask her mom to buy her the box with the largest volume. Okay, now one thing I'm going to use to try and organize my information here is I'm going to use two different colored markers, much like I would if I was using the smartboard in our classroom. I'm also going to name these two boxes to try and keep our volume work separate. Okay, this one I'm going to call box 1, and this one let's call it box 2. And really when I get started on the work for this one, I'm going to use a red marker. So I should have labeled it with a red marker, but that's okay. Okay, now, again, we want to find which box has the greatest or largest volume. And I'm going to start by doing my work over here for box 1. And again, we're going to use that volume formula. We know that volume is equal to length times width times height. So I'm going to pull out those measurements from my box, and I'm going to start working on that. I'm going to rewrite this. Remember, we're working step by step here. Volume equals 16 times 7 times 7. Whew, this looks like some tricky multiplication we're going to be doing here. Now, I am going to start with what I know right away. And I know that 7 times 7 is 49. And then we're going to be multiplying 49 times 16. Now, again, I have no idea what the product of 49 and 16 are, but I do know a strategy that can help me solve that. And I'm going to keep modeling for you, and I'm hoping you guys are getting more comfort using the standard algorithm for multiplication. So I'm going to multiply 49 times 16. And this is actually going to be the first 2-digit times 2-digit multiplication problem that I've done modeling for you guys using the standard algorithm, because there's one thing that's a little bit different here. Okay, I'm going to start with my ones place. I'm going to multiply 6 times 9 is 54. And then I'm going to multiply right here. 6 times 4 is 24, plus 5 is 29. Okay, now, here's the tricky part with doing the standard algorithm, and that one thing you really need to remember, and I'm also going to cross this 5 out so I don't get confused. When we are multiplying out our 1 in our tens place, what we're really doing is multiplying 10 times 9 and 10 times 40, not 1 times 9 and 1 times 4. So in order for our algorithm to work, we need to put a placeholder here. I know some of you like to do a 0. I like to do an X so it really stands out and then I know I won't forget it. Okay, now I'm going to multiply 1 times 9 and put that product right here as 9. And then 1 times 4, and that product again is 4, is going to go right here. Now, once I have those, I'm going to add them together, and then that sum is going to be our final answer. So 4 plus my x, which represents a 0, is 4. 9 plus 9 is 18. And 2 plus 1 is 3, plus 4 is 7. Okay, so what we found is that our volume of box 1, I'm going to write it right here, volume of box 1 is 784 cubic millimeters. Okay. Okay, I'm just going to kind of draw a box around that so it stands out. Now, like I told you, I'm going to switch to my red marker for us to find the volume of box 2. And we're going to find our volume the exact same way. So I'm right here, I'm going to write box 2. Even though we already know we're doing box 2, I'm going to write my volume formula. Length times width times height. And then I'm going to plug my values in from my rectangular prism. 28 times 5 times 6. Okay, now I'm again going to start with what I see right here, and I know right away. I know 5 times 6 is 30. And then I'm going to bring down what I haven't worked with yet, which is 28 times 30. Okay, now here, this is a little bit easier. And we worked on multiplying by multiples of tens and hundreds and thousands way back in September during our first unit of math. I am going to start by multiplying 28 times 3. Okay, and actually, I'm going to write that 3 right here. Sorry about that. That was not very organized of me. And then I'm going to put my 0 right here, and I'm going to bring that 0 down as the last part of my product because I know that if I multiply 3 times 10, that's 30. That means 30 is 10 times greater than 3. Okay, 8 times 3 is 24, and 3 times 2 is 6. Plus 2 is 8, and I'm going to add my 0 here. Now, the only reason why I can just say I'm just going to add that 0 here is because if we used our standard algorithm, this whole first row here would be 0 times 8 is 0, 0 times 2 is 0, and then our placeholder, we'd just bring down that 0 anyways. So our volume of box 2 is equal to 840 cubic millimeters. Okay, now that those are not really the answers to our question though. We want to figure out which of the two boxes Tasha is going to pick if she wants the most candy. So go ahead and look at these two volumes and compare them. And I see that the volume of box 2 is greater than the volume of box 1. So Tasha should pick box 2. Yay, that should be her pick if she wants the most candy.